Welcome to part one of our notes on erosion. If you can recall, the last set of notes were on weathering and this is on erosion. A lot of times you hear those two words go hand in hand, weathering and erosion. Where weathering is the process that breaks down the rocks, where erosion is a process that moves those broken down pieces of rocks, those weathered sediments, from one location to another. Now, ultimately, we're going to talk about several causes of erosion, and sometimes they call these causes agents of erosion. And we're going to talk about gravity and wind in part one. In part two, we're going to talk about running water, and in a third part, we're going to talk about glaciers. Now, when we talk about what's happening here in Wisconsin, what's happening in the Baraboo area, there's two that we're really going to spend a little bit more time on, and that is the agents of running water and glaciers. These are the two most important to Wisconsin, and glaciers more so in the past and running water now. So on a test, if I ask you a question, what's the most important cause of erosion or agent of erosion in Wisconsin today, you would say running water. But if we look at overall to Wisconsin, you'd have to also include glaciers, and we see a lot of those glacial features right here in Baraboo. Now, agents of erosion require energy of motion. In other words, they need energy in order to move. Now, a reduction in energy of motion leads to deposition. And deposition is the dropping of sediment. So when we talk about all these different agents of erosion, we're going to be talking about energy. We're going to be talking about energy of motion, we're going to be talking about deposition, and that will be a theme that will be reoccurring through all three parts 1, 2, and 3 on erosion. So let's begin by talking about gravity. In Wisconsin, we don't really have the really tall mountains that you might expect to find out in places like Colorado. So gravity's, yes, there is going to be some gravity taking place. Obviously there's gravity taking place, but when it comes to erosion, gravity will not have a profound effect on erosion here in Wisconsin. So what is it? Well, gravity can cause loose materials to move down a slope. When gravity alone causes materials to move down slope, it's called a mass movement. Again, we don't have the tall mountains. We have some steep-sided hills. And even when you're going down, if you remember, let's imagine that you're taking Highway 12 from Baraboo to Sauk. As you go up and over the bluffs, you see a couple signs that say watch for falling rocks. And every once in a while you'll see some bigger chunks of rocks lying right next to the side of the road. So yes, do we have mass movements here in Wisconsin? You bet. Is it going to be a chief source of erosion? No, not by any stretch of the imagination. Now, one type of mass movement is called a slump. And a slump is when loose materials or rock layers break downward as one large mass. So when we take a look at this, this is just a hand-drawn diagram, but you can see how this large piece, let me see, there's the pen working. See, this large piece all broke off together. A lot of times you're going to have trees falling, and the whole thing moves down as one large mass. So for example, this one right here, you can see how it broke from up here, and it probably dropped a good 5-6 feet, but the whole thing, this whole thing moved together. This would be considered slump. Here's probably a better example. So you can see how it started up here and this whole thing slid down, but you can see all the grass still on top of it. There are no trees here. So you don't see the trees, but all the grass is still intact. This would be considered slump. And I'm not sure what's happening here. I'm not sure if this whole thing right here slid down a few feet. I'm not sure why that continues to happen. Sorry about those technical difficulties, but this whole thing slid down several feet, and that's probably what's happening there. But you can see this whole piece came here, and from the looks of it, there should be a road going right through here, but most of the houses on this side have been buried. Now, creep is similar to a slump. However, with creep, sediments move downhill very slowly. So if you think of someone creeping around, they're moving very slowly. You might be on your tippy toes, like I might be creeping up to my son to scare him. You think of someone moving very slowly. That's what creep is going to be. It's going to be that downward motion of the soil, but it's going to move very, very slowly. And like it says here, sometimes it can cause posts to lean because that top layer right here, you can see how it's just bending down this way. It may cause these posts to lean. So when we look at this tree right here, more than likely at one time this tree was straight up and it was forced to bend this way. But then trees are kind of unique where they want to get sun. So even though it was leaning this way at one point in time when it was young, it still continued to grow straight up because it wanted to be able to get at its sun. So this would be a good sign that creep is happening, and you can see the hillside right here. So here's creep happening. I'm not really sure how they took this picture. It's kind of neat. It's a cross view or a side view, and you can see how creep is happening. So with that angle, you can see everything slowly moving that way. And so this is what can happen with creep. Things can just slowly slide, slowly move. It's not going to necessarily move very fast, where if with slump, the whole thing can move really quickly. Now, rock slides are blocks of rock that break loose and tumble quickly to the bottom. Again, here in Wisconsin, we're not going to have rock slides very often. Now, here's an interesting, well, the next slide I think is an interesting picture, not necessarily of rock slides, but a rock slide. And mud flows, I'll show you some pictures of mud flows coming up, but it's when water mixes with soil and moves downhill very quickly. So this would be considered a rock slide. Now it's not rock slides, it was just one rock. And on April 24th, 1995, and I can remember this happening, I actually went to school in La Crosse, so this is not too far from La Crosse, and this was big news back in the day. But this 55-ton boulder, remember a ton is 2,000 pounds, but this 55-ton boulder suddenly rode 400 feet down a cliff along the Mississippi River. If you've been up and down the Mississippi River, there's lots of places like in La Crosse where you've got bluffs, and they can be 400 or 500 feet high, so you're going to have some steeper areas in the state there. And this rock came rolling down the hill, and well, it ended up going right into this house. So here we can see some pictures of it. Last I heard, the house is ruined. They didn't try and fix it, didn't try and move the rock. But you see this gentleman juggling here? What they actually did was they opened the house up for a while, and I'm not sure if it's still open or not, but they were trying to get people to pay to come and see this rock. So he was out there entertaining people, trying to get them to come and see this rock, and hopefully to make some money off this mishap. And if you want to know where that happened, we created this little map here for you. So here's Baraboo. If you would take 90, 94, and then take 90 into La Crosse and just follow 35 up, 35 basically follows the Wisconsin River here. If you take it up, here's where your Fountain City would be. Now here's Coon Valley, and again you can see it's pretty steep here, pretty steep embankment, but you can see some rocks here that have fallen down, have slid down hill. So again, if you were in a car and your car ran into this, if this rock made it all the way out to the road, it would do some major damage. So do we have rock slides here in Wisconsin? Yes. Are they very common? No, not very much. Now what we're looking at here, remember we talked about rock slides, but we also talked about a mud flow. Sometimes this is called a mudslide. So it's not going to be a slump. You don't see the grass here like you did in some of the other ones. But here, again, it's going to happen on your steeper sides. The water is going to be mixing with the sand or the soil. It's going to be weakened, and then eventually it's going to break loose and it's going to flow downhill. So again, if we look off here to the side, it looks like there should be a whole row of houses that are right here. And the roads should be coming here, and it looks like there's a road right here going through. So you can probably see 10 or 15 houses that have been covered by this mud flow. So again, mud flows can be very damaging. Here you see one too. And the interesting thing about this mud flow is, look, here's where it started. Back in here it almost looks like, maybe even further back. But look how far it went down. There happened to be a street right there. So there weren't all these houses blocking its path. But you can see that mud flow just went and went. And finally down here there is a house. You can barely see it that stopped it. Otherwise that mud flow might have gone 200, 300, 400 yards. So let's talk about wind next. Wind has little, if any, effect on bedrock, at least wind by itself. But wind abrasion is produced by the sand blasting as wind carrying dust, sand, and fine gravel. So again, wind will not cause a lot of effect on bedrock. It will do very little to bedrock. But once the wind starts picking up the sand, it will start to break it down. And that's going to be your weathering. The erosion part is the wind actually picking up the sand and moving it. Now, wind deflation is when the wind blows small particles away and leaves larger pieces behind. And you'll see some wind deflation coming up in some of my slides. So here's the Badlands. Again, a lot of the loose particles have been picked up and gone, and this is the more resistant particles. You've got the Needles Park in South Dakota. Again, the wind whipping through these features, a lot of the softer material has been blown away, a lot of the harder materials left behind. And this next slide is one of the classics. You've got your natural arches, where wind abrasion has taken away even the inside of this arch. Of course, it wasn't an arch back then. It was probably the same as what you see off in the foreground right here. But the wind just kept blowing, and they had softer particles, say, in the middle, and eventually those were taken out, and what's left behind is your more resistant stone or rock, and you get these natural arches. Now, when wind picks it up, several things will happen. First of all, if wind's strong enough and the particles are small enough, it will completely pick up the particles and it will move them. This is your sandstorm. And if you think, well, sandstorms never happen in the United States, they do. They've had some in Arizona. So we do have sandstorms here in the United States. And a sandstorm is when the wind picks up the sand and it just carries it. Saltation is when the particles are heavy enough and the wind's not necessarily going to be able to pick it up and just move it outright, but it'll pick it up for short periods of time. Maybe there's a gust of wind and the wind's blowing a little bit faster. It'll pick up that particle, it'll carry it for a little bit, and then it'll put it down. It's kind of similar to us. If we're carrying something really heavy, we might pick it up, take 10, 15 steps, and we have to set it down. And then we'll try and do that again. The wind will do the same thing. And then creep, if you remember when we talked about gravity, creep is just a slow moving soil or top layer of, could be sand, it could be a lot of times it's going to be your soil where it just slowly moves downhill. Well, creep is similar to that here, where these particles are large enough, it's not going to be picked up by the wind. They're just they're too large. But what it'll do, it'll blow it or move it along the edge. So it'd be like a crate. If there's a box or a crate, something too heavy for us to pick up, what do? We drag it along on the ground. Well, wind will do the exact same thing. Now, wind deposits are created when the wind loses speed and or strikes an obstruction. Remember, in order to get energy of motion, you have to have a lot of energy. So if you lose the speed, you lose that energy, that's when you're going to get deposition taking place. And one of the chief deposits that's made from these wind-blown sediments are dunes. Dunes are hills of wind-deposited sand. And sand ripples are your miniature dunes found on beaches. Now, before we go any further, I do want to talk about one word. And I'm going to write it down here, just because it's not in our notes, but you're going to see it. It's L-O-E-S-S. Now, I've seen that pronounced a couple different ways. One is lus, another one is less. And I like less. So it's kind of sounds like, you know, your L-E-S-S, less. And what less is, it's wind deposited, I don't want to say sand, but it's wind deposited silt, clay. It's your finer materials, and less tends to be very common in the Midwest. So it's wind blown sediments. It's not going to be sand, but it's going to be your fine particles. It could be sand, but very fine particles of sand. But a lot of times it's going to be your silt and your clay. So if you're doing your review questions and it come across less, you can think of it as wind deposited silts and clay. And these are prevalent, quite prevalent, very common here in the Midwest. So just wanted to bring that up. Now let's go back to our wind deposit, dunes and sand ripples. So here we see dunes, and we've seen dunes. We've seen them in the movies. Maybe some of you have been to see some dunes. Some people say, well, I haven't been to a desert. You don't necessarily need to get all the way to a desert to see sand dunes. If you go to the east side of the Lake Michigan, on the Michigan side, there's actually some dunes over there that you can see that are a lot closer than having to go out to the nearest desert. And dunes can travel. When you look at this, you might say, wow, here's a city. Why are they building a city right here next to all these sand dunes? Well, the city was there first, but sand will migrate and it'll move, and we'll see that coming up in a couple slides. So this city is going to have a major problem. They're going to have to figure out what to do. How are they going to prevent this sand from moving in? Are they going to every day go out there and spend money by sweeping up all the sand, cleaning it up, and keep moving it back? Or is the sand ultimately going to win? One thing they can do if they have a lot of water there is they can try and, wet this down, get some topsoils on there, maybe plant some cover, some vegetation to cover it up to prevent it from blowing. But I'll show you another slide where there used to be a forest, but the sand moved right in. So how do these sand dunes move? Well, if you can imagine the wind blowing here, what it's going to do is it's going to pick up all the sand on this side of the dune, and it's going to take it and it's going to blow it over. Now once it gets to the side, if this is the way that the wind is blowing, and you can see it is, so it's blowing this way, once it gets to the other side there is no wind, and if you have no energy of motion, what happens? Well, it gets deposited. So the sand just keeps coming here and the wind blows it here and it settles on this side. So what happens is it just keeps moving and keeps moving and keep moving, and you can see it here where it used to be here, then it moves here, and then it moves here, and it's just going to keep moving and moving and moving as long as the wind's blowing that way. Now if the wind shifts directions, it's going to move in a different direction. And here a couple of things happening in this slide. One, you can see the mini sand ripples. Now here in Wisconsin we don't necessarily have a lot of these sand ripples, but sometimes if we have a really fine snow, if you go out there, and I know right after we presented the notes one year, I had the kids go out and look for this, and they all came back and said, yeah, we saw the ripples, they're in the snow. So they wouldn't be called sand ripples, it might be called snow ripples. But sometimes when we have a lot of blowing with snow, you also see these ripples. So I wanted to point that out. So you have the bigger dunes back here, you have the smaller little mini sand ripples right here. But the interesting thing is all these trees. This used to be a forest. And what had happened was that the sand migrated in and it basically destroyed the forest. Well, that does end part one of our notes. If you have any questions about erosion, at least as far as when it comes to wind and gravity, just let me know. I'll be happy to answer any of your questions in class. Thank you.